would like to talk about concavity in the context of curve sketching. So there can be two types of concavity of a curve, concave up and concave down. This pattern is concave up, we can say CU, and this one is concave down, we can say CD. Now these concave up and down curves can be divided into two parts. So this part where I will draw it, this part, in this part for the concave up curve, what's happening is f prime x is negative. So the first derivative is negative. The reason is the gradient is always negative up to here, and here the gradient becomes 0 because this is the minima point, and this part is where f prime x, that is the first derivative, the gradient is positive. So this part is often said concave up decreasing, DEC maybe, and this one is concave up but increasing, INC. Similarly for concave down curve, up to here the gradient is positive, greater than 0. So the first derivative is greater than 0, and it can be said this one is concave down increasing. This part is increasing, INC, and this part from the maxima point towards the right, it's always the gradient is negative. So first derivative is gradient is negative, first derivative is less than 0, and this one is often said concave down decreasing, DEC. Now how to find the concavity of a curve for if the function is given? We look at the second derivative, and if the second derivative is greater than 0, this one is concave up, and if the second derivative is less than 0, this one is concave down. And why it is so, we can see a concave up curve if we look at it, and if we see look at the gradients at various points. So here the gradient becomes 0, and then gradient like that, going like that, like that. So essentially the second derivative means it is the rate of change of first derivative. So how the gradient is changing, that's what second derivative says. So how the gradient, that is how the first derivative is changing, that is what can be found from the second derivative. And if we look at this curve, the gradient is always positive. The second derivative is always positive because the gradient is always increasing in the sense this is a very high negative gradient. The negativity keeps decreasing towards the right as long as it goes this way, as we go this way, and here the gradient becomes least negative and it becomes 0 at the minima point, and then the gradient starts to become positive, and the positivity keeps increasing. So if we say, if we at one point like if we do like that, so what I'm trying to say is 2 points and the gradient is like that. So this is a gradient at a point to the right, f2 is somewhere here and f1 is somewhere here, and the gradients at these two different points are the second point. From the second point to the first point, the gradient is subtracted. It will always be a positive number for a concave down curve, a concave up curve. That's why when the second derivative is positive, we can say in that region the curve is a concave up. Similarly for concave down curve, if we look at this one, the gradient here, I will use a different color maybe. So gradient here and then here, it's positive. It was initially the highest positive value, then the positivity keeps decreasing, and here it is 0, and then it becomes negative, and the negativity of the gradient keeps increasing. So always that rate of change of gradient is negative. That's why when f double prime x is less than 0 or it's negative, we know that in this portion the curve is concave down, because the gradient is always becoming negative, less and towards negative. So if we do, let's say the gradient here is f2 dot x and at here is f1 dot x. So if we do this calculation for any 2 points when f2 is a point of higher x value, so it will always be negative for the concave down curve. So this is why we can find the concavity of a curve in any portion from these two, looking at these two natures. And also one more thing is, when the second derivative is 0, that is called a point of inflection. That means when the concavity changes. So like if we have a curve like that, this one, and then like that, that means up to here this one is, so up to this point the curve is concave down, and from here to here the curve is concave up. So this is a point where the concavity changes, and that point is called point of inflection. And this one is, at this point the f double prime x is 0. And when we can find the point of inflection by just equating the second derivative to 0 and solving for x, and then we check the concavity on either side of that point by just doing point test. So looking at the second derivative sign here and looking at the second derivative sign here. So I will do examples later which will reveal more about these properties.